Welcome. Now please note, if you did not actually do the challenge but you just want to look at the solutions I came up with, then I officially claim you as pretty lame. No, okay, I know you rock, but honestly, you can't be taught. You have to learn yourself, and the only way you're going to learn is to mess around with the programs and play with the circuits. So what are some good ways to mess around with programs and circuits? So I take an approach called the Z principle. Z is actually the nickname for my son. He's a toddler right now. So what I do is I try to break everything I touch. I try to push everything to the limit. So I'll ask things like, how fast can I make this happen? How slow could I make this happen? Would this break if I tried this? So why do I do things like this? Well, there's a couple reasons. Now, first off, when you learn something new, you're generally going to learn its standard implementation. So you're already going to kind of have an understanding of how it's supposed to work. But when you start to discover the upper and lower bounds of what something can do, it really adds to your depth of knowledge and how something might be applied that you would only conjecture if you really didn't try it yourself. Now, secondly, sometimes cool things happen at the limits. So the behavior of a component may radically change at its limit. It could catch on fire. Or the operation of function may return unexpected values when it's at one of its limits. So possibilities truly lurk at limits, but you will never know until you push that limit or, read a data sheet, but hey, whatever. So let's go ahead and jump into this challenge now. Now there's about 1 million ways to do things in programming, so let's just compare our answers. I'm sure you got, there's no right answers, what I'm trying to say. So let's tackle this first challenge. It's change the value of the delay functions, and let's see what happens. There are 2 delay functions in the loop block of code. The first one controls how long pin 13 stays high. So this is when the LED is on. So the first one's kind of like an on switch. And the next delay function in the loop controls how long low voltage is written to pin 13. So this is when the LED is off. So this is kind of like the off switch. So in the loop function block of code, let's go ahead and change the first value in the delay from 1000 down to 500. So go ahead and upload that and take a look and see what happens at the board. So what we should see is that essentially this cuts the on time of the LED in half. So now it stays on half a second and then turns off for a full second. So now let's change the second delay function from 1000 down to 250. So we're going to quarter it, and then we'll go ahead and upload that. And now we should see a reduction in the off time. So now it should be on for half a second and then off for a quarter second, on for half a second, off for a quarter second. So the LED's blinking pretty quick. So how fast can we actually blink this thing? So I'm going to reduce the first delay function down to 200. And then I'm going to reduce the second delay function down to 100. And let's go ahead and upload that. That's blinking pretty fast. It's pretty cool. So now let's reduce the second one down to 50. Upload that. Let's see what happens. Okay, it's blinking faster yet. So now what I'm going to do is I'm going to reduce the first delay down to 5 and the second delay down to 5, and I'm going to see what that does. Now, do you notice something happen? If you look at the LED on your board, the LED does not blink anymore when it gets below about 5-second delay time. Now, why might this be? Now, you might notice that it does you might perceive a pulse, and actually on the video you might perceive a blink. Well, I can positively tell you that the LED is blinking for sure. It just blinks so fast that our eyes cannot perceive that it is actually blinking. And this is actually a physiological property of human vision. So if you're a cyborg, you can disregard that statement. But it's called persistence of vision, and it comes in handy all over this place, especially when designing LED matrices. So now let's go ahead and jump on to the second challenge. And that was change the number of the LED variable to 12 and adjust the resistor appropriately, and then see what happens. So I'm going to go ahead and set these back to the nominal values, which was a second on and a second off. And then I'm going to go up to the LED pin and I'm going to change it to 12. And then I'm going to make sure that I change the resistor on the Arduino to pin 12, and I'm going to go ahead and upload it and see what happens. So that's pretty much it. You can see all you have to do is reassign the pin number, and everything changes for you. Because we're using that LED variable throughout the sketch, you only have to change it once. And that's why it's really important to use variables as opposed to hard solid numbers. Because we could have put a 12 right here, then we could have put a 12 there and a 12 there, but if we wanted to change it, we'd have to change 3 times as opposed to just once. Okay, so let's change it to 10 and see what happens. So change it to 10 and upload it. Change it on the board, and you can see it's working fine. Okay, now let's try, what about those analog pins? Why don't we try one of the analog pins? So how do we address that? Well, we address those, we'll just use an A0. Okay, let's upload that, and I'll change it on the board also, and take a look at that. Okay, so we can see it's working. Now you might, depending on how long your LED and your resistor is, you might have to use a breadboard to make that connection, but you can see that it works fine just addressing it. So let's try pin 14. Let's change this to 14 and upload that. Now, when you change it on your board, you might be wondering, well, hey, wait a second. There is no pin 14 on the Arduino board. Well, hey, this is a little secret. The analog pins, you can use them just like digital pins, and you can even address them like a digital pin. So A0 is actually pin 14, A1 is pin 15, and so on up to A5. So it's just a continuation of the digital pins to address them. So let's just go ahead, we'll check out that, upload that, and check that out on the board, and you can see that. So really, the take home here is that the analog pins can be used just like any of the digital pins. So hey, that's the challenge. I hope you taught yourself something as you did that, and you know, I'm curious what things you tried, and if you were able to push limits and break something. Let me know. Alright, have a great one. See you at the next tutorial.